So let's try and figure out acceleration. We have a few problems, or a few formulas. I'm going to write them over here on the side. We have A equals change in V over change in T. We have VF equals VI plus AT. We have DF equals DI plus VI TF, I'm just putting that in parentheses, plus 1/2 A T squared. And this is your final time. So I can try and put that in parentheses. I hope that's not too hard to read. And then you have VF squared equals VI plus 2A DF minus DI. Okay. Now, in this problem, they say your automobile is starting at rest. Okay, so that's a VI of 0 meters per second. And then they say it speeds up at 3.5 meters per second squared. Now, it does not say acceleration, it says speeds up. But if you see this squared, you know that that is your acceleration. I'm just going to put a positive here. And when we want to know how far, that's your final distance. How far is it gone when it's finally traveling at 25 meters per second? So that 25 meters per second is your final velocity. A lot of students, they just pick out these numbers and they don't see the rest and show that that rest means 0 meters per second. So that's something they'll just like go quickly through the problem and not really read it very well, and they'll miss that. So we have an initial velocity, an acceleration, a distance, and a final velocity. And we want to find this final distance, okay? This equation, it doesn't have d in it at all, so we can't use it. This equation does not have d in it at all, so we can't use it. This equation has time, okay, and we don't know anything about time, so we can't use this one either. So we must use this equation, okay? And so that's how you can kind of try and you can figure out which one you need to use. And so now I'm just going to plug in my numbers. I have 25 meters per second squared. This should be squared here, I'm sorry. We have initial velocity of 0 meters per second squared plus 2 times our 3.5 meters per second squared acceleration times our final distance. Okay, this initial one is 0, so we can get rid of it. This is 0, we can get rid of that. So now we have 625 meters squared second squared. Remember, you see these two? The squared goes to both of them. So this gets squared, this gets squared, and this gets squared. Okay. And then we have 2 times 3.5, which is 7 meters per second squared, times your distance. I'm going to put it in parentheses so it doesn't get mixed up. Okay, so we need distance by himself. So I'm going to divide both sides by 7 meters per second squared. Now, I'm going to rewrite this again just to show you how the units cross out. Okay, so you have 625 meters per second squared. Meters squared, second squared. Then you have 7 meters seconds squared. Okay, so this second squared and this second squared will cross out. this m will cross out, and that will get rid of that squared m. And then you'll just have one m left. Luckily, right, that's the units you want for distance, so that works out perfect. That shows you set up everything right, and as long as you can type 625 divided by 7 in the calculator correctly, you will get the right answer. Okay, and I got 89.3 meters. Okay, and that's your answer. So you can see that we didn't have the time, but that was okay because we had these 4 different formulas and we could just pick which one we needed. If you look at this next formula, this next one, we'll see what we need for this. Again, I like to go ahead. I know this is going to be an acceleration problem, so I like to go ahead and draw my formulas. Okay, you might just have them in front of you because you have your formula sheet, or you can write them out for each problem. It doesn't matter. If you write them out for each problem, it's not like you're going to lose points or anything like that. And then our last one, this should be equals. Okay, now let's read the problem and see which formula we need. It says we're driving a car and we're traveling at a constant velocity of 25 meters per second. Okay, so our initial velocity this time is 25 meters per second. And then we see a child run into the road. It takes 0.45 seconds for you to react and apply the brakes. So that is your time, 0.45 seconds. Okay, so about 3/4 of a second. As a result, the car slows with a steady acceleration of 8.5 meters per second squared. Okay, so your acceleration, you are slowing down, so that's going to be a negative. And then you come to a stop. When you are at a stop, you are going a velocity of 0. So your final velocity is 0 meters per second. And then we're going to figure out the distance that the car moves before it stops. Okay, that final distance. Okay, this formula, again, it doesn't have distance, we can't use it. This formula does not have distance, we cannot use it. This one has distance, we have those. We have initial velocity, we have time, and we have acceleration. So we could use this one. We also have a final velocity, we have an initial velocity, we have an acceleration, and we have distance. So we could use this one too. We can use either one. I'm going to go ahead and pick this one. And the reason I'm going to pick this one is because I want final distance, and this is the one that has final distance on the side all by himself. And so I don't have to do any algebra, I can just plug my numbers in. So I'm going to have final distance equals my initial distance plus my initial velocity times my final time plus 1/2 a t squared. Okay, my initial distance is 0. Okay, my initial velocity is 25 meters per second. My initial time is 0.45 seconds. My acceleration is negative 8.5 meters per second squared. And my time is 0.45 seconds squared. Okay? So if you multiply these two together, you'll have 25 meters per second times 0.45 second. These two s's cross out, and you end up with 11.25 meters. Okay, in this one, you will have 1/2 times negative 8.5. That I think gives you 4.25. Okay, and then you're multiplying that by 0.45 squared, which is 0.2025 squared. So this s and this s will cancel out. Okay, and then you will have so this will be negative 0.861 meters. Okay, so you will end up having 11.25 meters minus 0.861 meters. Now, make sure that you don't forget this negative sign. Okay, make sure you continue it here and continue it here. If you don't, you will get the wrong answer. Okay, so make sure that you don't forget your negative sign, and you'll end up with like 10.39 meters. Okay, so the big thing for this one is figuring out which problem or which formula you want to use. Canceling out your units, again, it's a little more difficult to write it this way, but it lets you know that your units are right. And so it lets you know that you've gone through all this work and you're actually going to get the right answer. And then the third thing that's a little tricky with this problem is make sure that you do not forget these negatives. Okay, if you do, you'll get something more than 11.25, like 12 something, and you won't have the right answer. Now, 10.39 meters, that's about 30 feet. So hopefully the kid was more than 30 feet in front of you. Otherwise, he might get hit by your car. So be careful.